A ratio is a tool to compare two quantities. These can be the same type. If we had two lengths, this would be, or even like two volumes, this would be like scaling, a scale ratio. Or if we had different types of quantities, so like money and time, that could be thought of as like a wage, or mass and area, which is a pressure. Here I have a ratio between the lengths of the sides of this rectangle. I have 8 feet for the shorter length and 16 feet for the longer length. And I can write it like this, 8 feet to 16 feet. I can also use the colon notation, 8 feet to 16 feet, read the same way as this one. But I can also use a fraction, and that's typically what we're going to be seeing with mathematics, is this fraction. 8 feet over 16 feet, of course the feet cancel. If you cancel here, I can also reduce by 8 on top and bottom. And so 8 over 16 is the same thing as 1/2. And so we have 1/2 and then 8 over 16 if we cancel the units. That means that 1 foot to 2 feet is the same thing as this ratio. 1 foot to 2 feet, 8 to 16, 1 to 2, or in this case, it'd be double, right? This width here is the length is double the width. That's another way of thinking about this ratio. Now, the ratio 6 to 18 in simplest terms, we would write this as a fraction, 6 over 18. The first number is going to be in the numerator, the second one in the denominator. I can divide top and bottom by 6. That gives me 1/3. I can, of course, write this as 1, 2, 3, or I can write it as 1, 2, 3. Either one of these is a valid way of showing the ratio. In mathematics, though, like I said, the fraction is probably the best way of doing it. Okay, write the following ratios in simplest terms. Well, we have 4 to 12. That's the same thing as 1/3 as well. It's actually the exact same thing as 6 over 18 that we get 1 over 3 here. 14 to 28. Sorry, 14 to 42. I can divide top and bottom by 2. Gives me 7 over 21. And 7 over 21 is once again 1 to 3. So again, these are all the same ratio. It's just we're just looking at different types of formats for them. They can mean different things depending on the situation. Here I have 3 inch to 7 miles, so I'm going to write it as 3 inches to 7 miles. And this one says 48 millimeters to 42 millimeters. So 48 millimeters to 42 millimeters. This one can be reduced, right, by 2 is going to be 24 to 21. I can divide top and bottom by 3. That's going to give me 8 to 7. I can write it as 8 millimeters to 7 millimeters or 8 to 7. Either one of those things work for writing the ratio, but this is fine for what we wanted to talk about. Okay, in a bag of mixed nuts, we have 15 that are peanuts, 20 are almonds, and 5 were pistachios. What is the ratio of peanuts to almonds? So we have peanuts, 15 peanuts to 20 almonds. So we can write it as 15 P over 20A. This is, of course, the same thing as dividing top and bottom by 5. 3P over 4A. 3 peanuts to 4 almonds. You can also write it as just 3 to 4 as a ratio. It's saying 3 to 4 ratio of peanut to almonds, something like that. If we have two different quantities, like I had shown up here with money and time and mass and area, if we have two different quantities, we don't actually use it, call it as a ratio. We use specifically the word rate. So for rates, it's the same format as a ratio. We're going to have 30 miles in 4 hours. So 30 miles in 4 hours. And I can reduce top and bottom by 2. I get 15 miles per 2 hours. We want to keep the units in the rates because the rates units don't cancel like you did previously. They're not going to be the same units. So they need to be shown there. In this case, we have 24 inches to 4 feet divide top and bottom by 4, I get 6 inches for 1 foot. Of course, 1 foot is 12 inches, so this isn't a conversion ratio. This is actually a different kind of thing, maybe to like sides of a measurements on a machine, something like that. It could be a lot of different things. 12 boys to 18 girls. I'll write like this: 12 boys to 18 girls. Divide top and bottom by 6. I get 2 boys for every 3 girls. 18 cars to 32 bicycles. 18 cars, 32 bicycles. Divide top and bottom by 2 is going to be 9 cars to 16 bikes. Okay, 48 gallons for 14 minutes. Divide top and bottom by 2. It's going to give me 24 gallons in 7 minutes. Okay, and 72 correct answers out of 96 questions. We have 72, I'll say 72 correct out of the 96 questions total. Divide top and bottom by 2. It's going to give me 36 correct out of 48 questions. I can divide top and bottom by 6. That's going to give 6 correct out of 8 questions, or in other words, divided by 2, we get 3 correct out of every 4 questions. So we got 3/4 of the test correct. That'd be a way of interpreting that rate. Now, a unit rate is the same thing as a rate, but with a denominator of 1. We find unit rates by just doing these divisions for these ones. Of course, this one right here is actually a unit rate, but the rest of them we can find a unit rates by just doing the division and moving on from there. We're going to write the units slightly different for a unit rate, and that kind of depends on the part that you're talking about. So if a car can drive 561 miles with 15 gallons of gas, then the unit rates, which would be miles per gallon, or MPG, miles per gallon, is 561 divided by 15. And plugging it in a calculator, I get 37.4, and I'm going to write like this, miles per gallon. So the car can go 37.4 miles on a single gallon of gas. Now, some unit rates are not helpful, like this one here, 12 men to 15 women. A unit rate for this one, if I just do 12 divided by 15, I get 0.8 men to every 1 woman. But of course, you can't have 0.8 of a man. So that's the reason why this unit rate is probably better, or this rate is probably better to think of it in terms of dividing top and bottom by 3. It's going to give us 4/5 men to women. So that's probably a better way of thinking about that one. But for the rest of these, just do the division, and that will give us the unit rate. So 150 miles in 3 hours. 150 divided by 3 equals 50 miles per hour. This, of course, is a speed. 24 kilometers to 2 centimeters. 24 kilometers to 2 centimeters equals 12 kilometers per centimeter. This could be, for instance, a scaling measurement for like a map. 1825 for 4 gallons. Do that on a calculator. I get $4.5625 per gallon. Of course, this could be like a price for gasoline. And then 145 for 6 ounces is going to be 0.24, and then 16 repeating. I'll just write it as 0.24. This one should also actually have been, it's approximately equal to $4.56 per gallon, since we're talking about a dollar amount here, rounding to two places. The same thing here is going to be dollars per ounce. This, of course, is the unit rate, maybe for like an onion or something like that.